Hello and welcome. This session is about ASE61850 SCL Manager, that is ASC System Configuration Tool. And we'll be focusing in this session on our reusable engineering focus. So in reusable engineering, we will talk about pre-engineered bay templates with virtual IEDs. This is a concept that you can leverage to add more fine-grained detail to your system specification descriptions or SSDs. We'll also talk about the replace IED use case with multiple specific use cases. So there are three use cases which are commonly encountered in utilities with regard to SCL engineering, which are all implemented in SCL Manager using one feature, that is replace IED. The first of these use cases is about bay templates. Now, bay templates is a way where utilities can create or pre-create engineered bays using vendor agnostic dummy IEDs, that are virtual IEDs. Using this method, you can do a lot more than a conventional SSD. In a conventional SSD, you just have single line diagrams and functions, but here those functions can be referenced to these virtual IEDs, and you can perform complete engineering of those virtual IEDs with respect to datasets, reports, rules, and signal mappings. Now this bay template is incomplete without the second stage, that is to replace that bay template with real IEDs in an automated manner. And that is the use case that we will demonstrate first with the replace IED feature. And the second feature is another use case which is commonly encountered, that is when a vendor's ICD file changes while you have already completed engineering of a project, or you have made progress and made partway engineering of the project, and you need to restart with the new ICD file. So to update that ICD file into your partly or fully engineered project and retain all the existing engineering and configuration is the second use case that we will demonstrate. And finally, as a last use case is the what is known as a bottom-up engineering approach, where you have a fully configured SCD file that is used by the ICT or IED configuration tool, and at that stage the ICT makes changes to the configuration, maybe with respect to some internal logic or internal addresses or anything, and now that those changes need to be brought back into the system configuration tool. This is usually done by the ICT exporting a IID file, that is an instantiated IED description. So merging that IID file back into the project is again another replace use case, where you want to replace the current version of the instantiated IED in the project with the new modified IID file. So that is the third use case that we will cover. We'll start with the first one. Bay templates. What is the benefit of doing bay templates? Well, with bay templates, you can do more than specifying functions. You can go into a more fine-grained detail of the kind of engineering you expect to receive. For example, this is a bay template for a typical feeder bay. In this, we have taken choices, like we have chosen that there should be a BCU in the system, which takes care of control commands. And we have decided that the process interface unit takes care of the switchgear and merging unit functions. And we have decided that the control commands to the BCU get transferred to the PIU using operate open and operate close as a goose message. We also choose to have two bay protection units, primary and secondary, or main and backup. So we'll have two kinds of trips, the main trip and the secondary trip. And we have sampled values from the PIU, which naturally needs to go to both the relays. So it is going to both the protection relays. And we can have breaker failure function in the secondary relay, which is used to update other bays. And we can have reclose and synchronization, which is also functions that in this case we have chosen to put in the secondary relay. And the off-close function, instead of going to the PIU, goes to the BCU, where the BCU can apply its logic before forwarding the reclose operation to the PIU. So you can make various design choices as to how the secondary equipment has to perform its function, and you can do this by creating virtual bay templates with virtual IEDs. But creating a template is not very much useful if you're just going to use it as a reference at the time of actual system integration. But SCL Manager allows you to use these templates and instantiate a real project To instantiate the real project, you take a copy of the virtual bay and you import IEDs that you choose to use, the real vendor ICD files, and you tell SCL Manager which IED is replacing which IED in your virtual template. And when you're done with that, SCL Manager will guide you through a process where you map the functions and everything else. All this signal mappings and engineering is automatically translated into the new bay. So at the end of this process, you will have a completely identical replica of your pre-engineered template, except that this will be entirely in terms of real vendor IDs using the real signals and real datasets and reports from these IEDs. So let us see a demonstration of this process. I have here a pre-created project with a virtual template. So I'll just open that in SCL Manager. The slide that you saw is a representation of this project. So here you have the single line diagram. You can see it's a simple feeder bay, an incoming feeder passing through a circuit breaker with two isolators and a CT and a PT and an earth switch. And various functions have been assigned: RBR, FXCBR, CSWI, etc. The functions have not only been assigned, they have been linked to the IEDs that perform those features. In this case, they have been linked to the virtual devices: V secondary protection unit, V process interface unit, V BCU, etc., etc. So you can see that all these functions, including 4 TCTRs, 4 TBTRs, and MMXU, and all the circuit breaker, control switch, interlocking, synchronization, breaker failure, everything has been mapped, and the protection trips, 2 protections and the corresponding trip conditioning functions have been mapped to these 5 devices which have been created using SCL Manager. If you look at the devices that have been created, the virtual BCU is a very simple BCU. All it has is one logical device, V_LD, with 2 logical nodes, that is CSWI and CILO. We have fleshed out the data model. So the CSWI has a type in which it does not have just the mandatory behavior and position, but we have also added the operate open and operate close because we intend to use that. The operate open and operate close have been used in data sets. For example, here the operate data set contains the operate open and the operate close, and that data set has been used in a goose. And in that goose, which we call the CSWI operate goose, we take all these signals and we map them to the destination, that is to the PIU. And within the PIU, you can see all those external references have been created with the operate open and the operate close. So all the mappings have been performed in this manner. Additionally, there's a report that is going with the positions of the breaker, positions of CSWI to the HMI. If you want to look at the signals, you can see the signals here. These are the inputs coming into this device, and this is the source from which the input is coming. These are the outputs going out from this device, and this is the location or the destination to which it is going. You can have a bigger picture of the entire project by looking at the external signals, where you can see all the signal matrix. You can slice and dice it, specify which source, which destination, all, sum, how much granularity you want. So here you can see the BCU has got the operate open, operate close, which is being sent to the PIU. It also has the CSWI positions, which is being sent as a report to the HMI. And the BCU these are the signals going out of the BCU, and the BCU is also a recipient for signals coming in from the PIU. The PIU is sending the XCBR position, block opening, and block closing values as a goose to the BCU, and the BCU is also receiving the synchronization release from the secondary BPU and the reclose signal of close from the secondary BPU. Now let's see how we can replace this BCU, which is a virtual device, with a real device and still have all these inputs and outputs retained without any disturbance. So to replace the IED, we need to add the IED first. So I'll go and import from a file folder. Instead of creating new or importing from a database, I have the files in a folder. So I have a vendor ICDs folder. So in this one, I will use the Siemens device as my BCU. So I select this, everything passes, validation is passed. The name of the IED is template, as it should be in an ICD file. So I import, and the import is completed. So now this device is here, and this is the full device. You can see 195 logical nodes. So I take my BCU, I right click and I say replace, and I select the template as the replacement and say OK. Now this is where the mapping happens. You already told SCL Manager that the BCU is to be replaced by the template IED, and now for the functions you need to specify the same thing. So the CSWI1, for example, you map it to the available CSWI1. This is green, this is also green. The node type is green, which means everything is matching. The entire structure of the CSW that I want, along with operate open, operate close, is available here. So this is fine. The only problem is behavior is not green because the initializer for STVAL is not available, which is something that's not a problem. I can always add it here. Okay. So now this is completely green, everything is okay. Now I can do the same thing for CILO, so I'll do that. I will not spend time on the data object initializers because it's not important for this demonstration to save time and keep this session short. So I've mapped the functions, and now the LLM0, because all my logical nodes are in this logical device, I could choose to take any of these, but I can choose this one. Okay. So I take this LLM0, and now I see the data sets and reports. This is my engineering from my virtual IED, which is not obviously not present in this ICD file. So I simply click, drag all these elements, both the data sets, then the report controls, and the cruise control, and finally the inputs, and all of them get created in the destination, that is in the replacement IED. They don't just get added, they get translated. So if you look at this data set, this virtual LD CSWI is the signal that was getting published by the virtual BCU, but in this case, line 1 underscore CB underscore L1 logical device slash CSWI1 is the signal being published by the real device. So everything gets translated, your data sets, your reports, your trigger ops, all your properties, including your goose, your address, everything gets translated across to the right side. It's not just copied, it is translated in terms of the signal references. Your inputs will not change now because your inputs reference signals coming into this device. For example, signal coming from PIU is still coming from virtual PIU. So there is no change here because even now, the new BCU, when you replace the BCU with this BCU, it will still continue to get signals from the virtual PIU. We have not replaced the virtual PIU yet. But in the second stage, I will do that as well. And then we'll come back to the BCU to see that even these names are also getting updated. So right now we are ready to perform the replacement. We have mapped everything. So I can just click on replace and the template disappears and we are left with the VBCU, which now has the complete real IED with so many logical devices, logical nodes, the data sets that we created, the goose that we wanted, the mapping, everything is present. You can go to the signals and you can verify they are there. And the easiest way, of course, is to go to the project signal matrix, and you can see that the BCU has gone down to the bottom because we just replaced it, but it's still the same. So in the BCU, you can see now the line 1 CBL1 has got a cease operate GCB, and the line 1 CBL1 CSWIs operate open and operate close are still going to the PIU. So there is no problem with this. And the line 1 CBL1's positions are going as a report to the HMI. These are the two sets of things that were coming out of the BCU. They are retained. And the BCU as a recipient is still getting all the old references. That is the PIU information, the XCDR positions. The positions, block opening and block closing are still coming in to this to the new BCU, and the synchronization release from the secondary BPU and the reclose GCB, the reclose signal from the secondary BPU are also still coming to the new BCU. So we have successfully replaced the BCU with a real vendor IED and not lost any of the inputs or the outputs or the signal mappings. Now let us perform the other case as well just to confirm this session. So let us also replace the PIU and come back to the BCU and see the changes are complete. So I add IED, I import, browse, and I use a Hitachi PIU. These are all files we received as part of the interoperability event that we attended. So we are just reusing those files here. So it's all valid. And I say finish. Now I have the Hitachi PIU. So I'll click on the vPIU and say replace with Hitachi. Now this is going to be a more involved example because the logical nodes we need are across a different structure with many different logical devices. So XCBR is here. I map it. I'm ignoring all the initializers. I go to TVTRs. I have a bunch of them here. So I go to U00A, U00B, U00C, and U00N. Similarly, I have TCTRs. I'll go to a different logical device. So I'll go here. I'll go here. TCTR3, TCTR4, and then I have an MMXU. So I click it here. I lost the drag, so here it is. Now it's done. Now the LLN0, I can pick any. I'll just, because I have data mapped to different structures across the breadth of the IED, I'll use the central one. The LD0 is there, so I can map it here. Again, the same procedure. Dataset, the report, the goose, sample values, and the inputs. So we are done. Now we can replace the PIU. And now if you go back to the BCU, we have the BCU open here. Okay. You can see that the signals coming from the PIU, now you can see it's updated. The signals coming from the PIU, this is a line 1 CBL1 is the recipient and this is the source. It's now coming from CTRL logical device. It's not V_LD. It's not a virtual logical device anymore. CTRL logical device, S3, XCBR1, etc., etc. So you can see that these are extras which are present in the BCU. They are also getting updated when we update the PIU. And signals going out are still the same. So you can again see back in the external signals, you can see that this is the BCU. We already verified that the BCU signals going out are still retained, and the BCU signals coming in from the secondary BPU are still the same ones, that is the virtual logical device synchronization and reclose, but the signals coming from the PIU have been updated because the PIU changed after the BCU changed. So now it is the CTRL S3 XCBR1 values which are mapped as extras inside the BCU. So this is also a complete example of a replacement. And of course the PIU itself, the PIU signals are all translated. You can see that the new PIU which we replaced now is still sending all the voltage, current and voltage samples. They have been changed to U00ABCN and I01ACTN, etc. And they're still being mapped to the main and the secondary BPUs. Not only this, you can even go back to the single line diagram and you can see your references have been updated. You can see the CTPT references have been updated, U00ABCN and I01ABCN. These are the values. MMXU is now from PIU/monitor. Monitor is the logical device. And then RBRF1, this is not changed because the secondary BPU we have not replaced yet, but the PIU we have replaced. You can see here the names have changed. This is again the BCU we have changed, so it's line 1 CBL1. So you can see here all the references back in the single line diagram have also been updated. So we can complete this process, and I have already done that. I have a pre-created project. So this is the replaced IEDs project in which everything has been replaced. The remaining 3 IEDs have also been replaced. So I'll just wait for it to load, and then I can show you the signal matrix. So in the new project, you can see the signal matrix. All the signals have been updated, okay, with the different logical devices. And you can see here the secondary BPU, which now has 558 logical nodes with multiple logical, everything, all the devices have been replaced in this project. So this is the first use case. We have successfully converted I took a few minutes to do the first two IEDs. Another 5 to 10 minutes would be sufficient to replace the entire Bay template with the real vendor IEDs. And we do not have to re-verify all the signal mappings. Whatever signal mappings and best case engineering has been done in the virtual template has been translated into your real world IEDs without additional effort. So this is the first use case. Now if we go back to our presentation, we have already covered this part. And we now have to come to the second use case. So in this use case, we are talking about a situation where the project is engineered either fully or partly. Some progress has been made, and there is a new ICD. The existing IEDs that is being used in the project, there's an updated ICD with some changes, maybe some changes in the data model, or maybe a firmware upgrade, or something has happened at the IED side. And there's a new ICD file. Now you don't want to restart from the beginning by importing, deleting the IED with all its engineering and restart from a fresh ICD. So here the use case is to replace an instantiated IED in a project with a new updated ICD without losing any of the existing engineering and the configuration. So let us take a look at this use case. So let me escape. I have my replaced IED project. I have a ICD modification project created, ready to modify my ICD file to create a variation, something that we can use. So this is an empty project. I have to load something. So I can load the, let's take the PIU file. So I take my vendor ICDs, and this is the PIU, and I open it, and I'm ready with the project. Now in the project, in my project for the PIU, I have a MMXU dataset, which is basically containing my MON logical device MMXU1. The data objects I have selected is the total active power, the phase voltages, and the phase currents. So we can make some changes to some of the underlying data model, which will make this dataset invalid. Okay. So I won't make a change here. I go back to my ICD modification. I go to my logical nodes, and I select that it was the MON, the monitoring logical device, the MMXU. I'm going to go ahead and change this data model. So it has behavior, total active power, phase voltages, and currents. So I'm going to remove, I'll remove the A, that is the phase currents, which is something that I'm using in my project. I'm going to remove this data object, and I can add some other irrelevant objects, say total apparent power. So now I've added the total apparent power. I'm just selecting the mandatory elements, none of the optionals. Doesn't matter, just for the demo. So now I have total apparent power, and I no longer have the phase currents in this data model. Okay, and I say okay. So I have modified this ICD file. I need to export this. So I can export, and I'll not put it in my vendor IDs. I'll put it in my root folder of my demo. So I have my Hitachi PIU. I'll call it my modified ICD file and save. All right. So I'm going to export that. Now I go back to my main project, which is where I have all my 5 IEDs. Everything is available. Okay. And this use case is that the system integrator has received a new updated ICD file for the PIU, which the vendor is asking to update into the project. So now I'm going to add that updated file. This is the one, PIU modified. Okay. I'm going to take that and update it into my project. right? Now I need to replace my PIU, which is already engineered with the old ICD, with a new ICD, where I know that the data model I have changed it. Okay, so I'm going to replace with Hitachi and say OK. Now, as you can see, the replace IED button is the same, the functionality is the same, but we have a different look. That is because we are no longer trying to replace a virtual device with a real device. We are trying to replace the same device with another instance of the same ICD with just minor changes. Okay, so now everything looks green because everything is matching. Not everything. SCL Manager warns you that there's something wrong with the MON logical device, and within the MON logical device you can see all the other logical nodes are okay, but MMXU is not okay. If you open that, you can see this is okay, this is blue, this is the part which has got a problem, that is a logical node type. And if you open that further, you can see very clearly that all the A data attributes, MX/A data attributes are missing. So this is the problem in this updated ICD file. So this has some impact on this project. This is where you need to take a decision. Is this important? So this is data that is going as a report. It's a measurement value. It's a report going to the HMI. So maybe it's not a serious problem. If it is a serious problem, this is where you need to stop and cancel. You can just close this mapping window and everything is retained, and you ask that ICD file be rolled back and something else be done for that. But if you're willing to proceed, you can go ahead and proceed with this. You cannot drag and add this into this element here, okay, because you cannot change the data model of an ICD file. So you can only do engineering. So we can continue to do our engineering. If you look at LLN0, you can see here, we need to add our engineering again because this is an updated ICD file. It does not have any of our engineering. It has the full structure because it is the same as ICD that was used initially. So it has a full structure, but it still does not have these elements. So we just complete the process like we did the last time. Okay. There is no changes. First the data sets, then the report controls, then the report controls. I get a drag there. Okay, now I got the drag. And then I have my goose controls. My mouse is clicking. My sample value controls. And finally my inputs. So I have added everything. Now you can see here again, this data set is warning you when you perform the mapping to this side. It's saying it's not exactly able to match because of the expected problem. The mx.a is no longer available to be mapped or translated to the other side. Okay. But we have decided to go ahead with this change, so we go ahead and say replace. And the replace is done. So if I go back to my, oh, it's not yet done. I think it's taking some time. Yes, it's done. And this is the signal matrix. And you can see here, we updated the PIU. So the PIU, everything else is the same, even though we did a complete. We pulled out the foundation of the engineered PIU by removing the model from beneath the engineering, and we replaced it with a new version of the ICD file. But everything that we did, all the engineering that we did, everything, the values going to sample values going to the BPUs, and the status is going to the BCU, and the PIU is still retained. Okay. The only difference, of course, is the MMXU report, which was going to the HMI, now has only two attributes. It has got the total active power and the phase voltages. The phase currents has disappeared. So this is as we expected. So there is a second use case where fresh template ICD file is provided after engineering has been done. Now, if we come back to the presentation, we just check this. Third use case is where the entire SCD is sent to the ICTs, the IED configuration tools. The IED configuration tool takes the SCD and performs engineering and instantiation of that IED. And at that stage, the system integrator may need to make some changes Typically, the changes may no longer be data model specific. It may be more to do with adding internal logic, and which may involve editing or adding internal addresses. And could be anything. Essentially, this process is similar to the previous use case. From SCL Manager's point of view, there is not much of a difference. This is going to be very similar to the previous use case of updating the ICD file, except that this time the file coming in already has a lot of engineering in it. So it still performs its job in exactly the same way. So let us do that. To do this, I'll keep this SCD as it is. I'll not edit it in place. I'm going to edit it outside. So let me export the SCD file. I'll export the complete SCD file right here. So I'll call it full SCD and save. Save. Okay. It adds some version information and the SCD file has been saved. Now I can take my ICD. Okay. So did not save that. Which says errors. There is a duplicate key sequence. Okay, this is some things that was left when I changed TVTR earlier. And the element subnetwork has incomplete. This is something that is coming from one of the ICD files as imported as subnetwork. You can see here this subnetwork or subnetwork 1 ends here, and it does not have the mandatory content. So here saying that it has incomplete content. Here is a list of possible elements. So I can force export, or I can just clean up this part. So I cancel the export and I can go to my project addressing. I have all my addressing information here. IED summary, host communication, sample value communication. You can edit, make changes to the network without going from each tab to tab. You can work on it in a tabular manner. So here, this is the first one. The first one, subnetwork 1. This is the name. This is the problematic subnetwork. So I can just delete that one. And I think that's all that I want to do. Let me export again, full SCD, save. Okay. Add one more version information. Now it still says the duplicate key sequences. That's okay. I'm going to go ahead. That's part of the substation section. So I'll go ahead and force export and say okay. Now my full SCD has been exported. And I'll use my other project, my ICD modification project. Okay, I'll use this. So I'm going to remove this. I'll remove the Hitachi PIU, which we earlier modified the ICD file. So I'll have an empty file again. And I can import the SCD file. So now I'm going to duplicate or impersonate the person working at the IED side, the ICT side. At the ICT side, IED configuration side, I'll be importing the SCD that has come from the system configuration tool. So I'll pick the full SCD and I'll use this to basically, we know what those errors are. So let me just go ahead and modify them automatically. Okay, and force import. So now I have my import. It gives me a choice of importing specifically substations or voltages or base. I just go ahead with the full import. And this is the section where specifying problems with some subnetworks, which we are anyway forcibly importing. So I'll say finish and let it import the 5 devices, and we are done. So now at the IED configuration stage, we are going to make some changes. So for example, what I can do is I can make changes while using this to program the devices. So for example, I could change the internal addresses. So now I have my operate open, and the system integrator performs some internal logic that triggered by the internal address. So he adds or edits the internal address. So this is the operate open. So he has logic here, command open, save. This is the close. So edit the input and say command close, save. This is the main trip. So maybe there's some logic, anything that needs to operate. This may not be a valid example. I'm just making strange changes. Main trip, and I have my secondary trip. So I call it secondary. Save. So this is some changes I've done. I could make changes in the data model also. It's not unusual and it's not a problem. It can still work in the same way that it did in the last use case. But in this case, I'll just stick with this much. And at this stage, the user wants to send this instantiated information back to merge with the original project. So that means I have to click on the PIU and export. And this time I'll be exporting it as an IID. That means I will call it an IID. The naming really doesn't matter. Just by putting this extension, it doesn't change anything. The content is what is there on the project. So in this project, the PIU has everything, including the engineering and now the newly added internal addresses. So I'm exporting it and I'm calling it as PIU, vpiu.iid. So I say save. So okay, export is complete. Now I come back to my first project, and the use case is that I have a PIU in the project, and the system integrator has come back saying that changes made at the IED programming side, and there's an IID that needs to be integrated back into the project. So I go and browse, and I pick up my, the filter was set there. So I say IID files, open. I have a vpiu IID. It changes the name to vpiu_1 inside because you cannot reuse the same IED name in a project. So that's okay. It's a temporary name anyway. So I finish. Now I have my vpiu1. So I take my real PIU and I'm planning to replace it with the new version which has come back from the IED programming stage, and say okay. Now it's again the same picture because the same structure. We no longer have any problem with the logic data model. You remember the monitor logical device, everything is fine because there's no change between these two data models. We did not change the data model again. The only things that changed is here. Now here you can again see LLN0 is blue, but most of it is green. That is because dataset, report control, everything is already there here. This is no longer an ICD, empty ICD file. It has got all the engineering that you sent to the SCD, to the IED programming stage. Only thing it has come back is with something changed. And the only thing that is changed, you can see here, inputs is blue. It is not in green. So it is saying that there is a change in the inputs. It's not the same. And if you open the inputs, you can very clearly see these are the 4 that we edited. 1, 2, 3, and 4. The 4 inputs that we edited is showing up as blue because they are no longer matching the values here. So here you can see the values that's coming in, and here it says that the description is different and the internal address is different. So here you can see there's no description. The description was missing earlier, okay, and the internal address is available here as CMD open. So it's saying that this is the change. Now you can again verify. You can see how quickly you can narrow down in a very large file to what has changed, and you can examine the change and understand that the only thing that has changed is basically the names, the internal addresses that have changed here. So this is again a solution to something that you can live with. You can absorb this IID file back into your project. So I can just go ahead and I don't have to do any mapping here. Everything is already mapped, and I'm going to accept these changes. Right? So the changes are already here. So I just need to say replace. And let it finish its job. Okay. So now if I go to my PIU, my PIU has been updated. If I go to my external signals, yes, you can see all the internal addresses have arrived. So everything else should be the same. You can validate it. So you say go to your external addresses, and yes, you can see now instead of just an X, SCL Manager marks with an X to show a mapping between a source and a destination. If that mapping does not have any internal address, it is blank. If it has an internal address, it uses the internal address at that junction. So it says that operate open general is command open in virtual PIU. So you see all the signals are still preserved. We again replace the PIU with another version of the PIU with full engineering and a few internal addresses. And now you can see all the inputs to the PIU have been migrated. and all the outputs from the PIU are still going out. So these are the signals going to the BCU, these are signals going from the PIU to the main and secondary BPU, and these are signals going as reports to values of MMXU going to the HMI. So with that, we have come to the end of this session. Essentially, we have seen 3 use cases. First one was virtual IEDs, creating an entire bay with virtual IEDs and replacing all the IEDs in the virtual IEDs in the bay with real IEDs to get a replica of that with real devices. The second use case was where you have an engineered project and somebody brings a blank ICD file, which is an update because something has changed in its data model or services or something inside the ICD is changed, and you want to update that under your configuration without removing all the configuration you did with the older version of the ICD file. And the third process is the bottom-up flow, part of your hybrid engineering solution, where you have a top-down flow and you still have changes that happen at the bottom and needs to come back up into your project. So all these 3 processes have been completed. So thank you very much, and we can continue onwards from here.